Hi, this is Kevin Trainer. Welcome to my lecture on um, Chapter 5 of the Kathy Schwalbe text, An Introduction to Project Management, 7th edition. And Chapter 5 is about planning projects, Part 2, schedule and cost management. And The slides here begin with a list of the learning objectives for the chapter, which I'm going to leave for you to read on your own. Um, okay, so uh, the uh, the Schwalbe text, I think, does a good job of covering the project management body of knowledge as created by PMI, uh, Project Management International. And uh, I'm sorry, the Project Management Institute. Uh, these acronyms. And the project management body of knowledge, also called the PMBOK, is, I think, a very valuable attempt to categorize the knowledge and the terms that have to do with formal project management. And so I really do think that the information from the PMBOK is useful to people interested in project management, no matter what kind of approach they're going to take. Now, the two basic approaches that we talk about in my course are the traditional, the predictive, the waterfall approach, which we call waterfall, even though some people use that as a pejorative term. And then the other option is the agile approach. Okay. Now, this chapter is primarily about the waterfall approach and the terms and um, techniques and all those things that come out of the waterfall side. There is some talk at the end of the chapter about the agile approach. It's not the only version of the agile approach that we're going to cover in my class, because we're also reading the Layton book on Agile, which has more details about the approach to schedule and cost in Agile. Okay. So here, what we see is here are two of the knowledge areas from the PMBOK: project schedule management, project cost management. And the process that's going on, you remember the other the other kind of aspect, the other kind of facet of classification that the PMBOK has is the 5 process groups, and one of the process groups is planning. Okay, and the processes include, for the schedule, project schedule management, define activities, sequence activities, estimate activity durations, and develop schedule. Okay, and I think this is a good group of things that have to be done. And with regard to cost, plan cost management, estimate costs, determine the budget. A lot of people might think that the costs and the budget are the same time, but the budget is the expected distribution of costs over time. So it has a calendar aspect, and that's what's the difference between the cost and the budget. The budget are the costs projected out over the calendar. Okay. Um, And then if you look at the first thing we're going to be talking about is the schedule and then the cost. If you look at the right-hand column on outputs, it gives you kind of all the things that you could come up with in order to support these activities. So in defined activities, you would have an activity list, activity attributes, a milestone list, change requests, project plan, project management plan updates, sequencing activities, a project schedule network diagram, estimate activity durations, project document updates, and it goes on and on and on. So these are, I think it's interesting to think of the process of scheduling a project as a series of activities. We just don't jump in and create a schedule. Okay? Now, if you think about what we talked about in the chapter before this, the part one of planning chapter, we primarily talked about the scope. Okay? And in that, for traditional or waterfall projects, we created a scope statement and a work breakdown structure, a WBS. Most people use the WBS as a way to brainstorm about activities. Okay, so when we talk about activity lists, activity attributes, milestone list, how do we come up with those things? Well, we come up with them by brainstorming off of um, the WBS. Okay, so even though we said in the last of the chapters that a proper uh, WBS doesn't include activities or tasks, um, that doesn't mean that we wouldn't use the WBS structure as a way to organize or brainstorm about activities or tasks. Once we've identified them all, we need to sequence them. So we need to know what kind of dependencies they have, and we're going to talk about this in the chapter. We have to know what their duration is, like how long they're going to take. We also have to figure out how much effort they're going to take, because that's going to mean um, um, not so how much effort they're going to take. I always think of software development projects because that's what I grew up on. But we need to know the resources that they're going to consume. Okay, now on a software development project, the primary resources that we're going to consume is person power, right? But we could in another kind of project, we could consume a lot of other things. We could consume lumber and concrete and all those things, right? Um, uh, and then eventually we're going to develop the schedule from all that information. And then when we come down to the cost, okay, as usual, the PMI folks have a plan for each of the plans. So uh, up when we're doing the scheduling, we have a schedule management plan, which is the plan for how we're going to do this part of the overall project plan. So and down when we're working on the cost, uh, they think that we should have a cost management plan, which is the plan for how we're going to uh, develop uh, the cost plan. Okay, so we need to come up with the cost estimates, the basis for the estimates, a cost baseline, project funding requirements, and we need to update the documents, right? So again, the chronology that they have here, that we estimate the cost and then we determine the budget, Again, I think they've got the chronology right because uh, the costs are just the costs they're going to be incurred regardless of when they're going to be incurred over the life of the project. But it's very important to managing the project well that we know uh, when we expect to spend the money. Because the question that comes up all the time when we're in the course of the project, how are we doing with respect to the budget? So we're going to want to know, well, what did we think we would have spent by now? Okay. So if we don't have a budget that plans out our costs over time, uh, well, we can certainly ask the accounting folks to add up how much we've spent so far. But if we didn't have any kind of a plan or a baseline for the budget, then we wouldn't be able to say, for instance, well, the total cost for this project is $1 million. We thought by the week that we're in right now that we would have spent 560,000 of those. Okay, well, we may want to compare it. Where are we? Are we at 300,000? Or are we at 900,000? Okay, so that's the big picture. Uh, so project schedule management for the predictive or waterfall approach involves the processes required to ensure timely completion of the project. The main planning tests performed include planning schedule management, defining activities, sequencing activities, what order do they happen in, estimating activity durations, that's how much time is going to elapse during that activity. Something that we don't say yet is what resources are they going to consume, especially if you're thinking about software projects, you're thinking about uh, how many person hours is that going to take? And then developing the project schedule. The main documents produced include schedule management plan, activity list and attributes, milestone list. We'll talk about the milestones, project schedule network diagram. Now, as we're practicing how to do that, we'll actually create a project schedule network diagram. Practitioners in the field usually use a project planning tool that has as its data model a network diagram. Okay, so often they don't draw diagrams per se, and yet the kind of scheduling algorithm that gets used on their schedules is based upon the network diagrams that we cover in the chapter. Activity duration estimates, a schedule baseline. Again, we say baseline for schedule, we say baseline for budget because it doesn't take long before things start to work out a little differently than we expected. And then the question is going to be, how are we doing compared to what our original plan was? How are we doing against the schedule? How are we doing against the budget? Well, if you didn't save the baselines for either of those, you have nothing to compare to. Hence the value of saving a baseline schedule and a baseline budget. Okay? Okay, contents of a schedule management plan. Now, whether you're going to have a written schedule management plan, again, is going to depend on how big of a project you're going to do. Okay, and how different is this project from ones that you and your colleagues work on all the time? Uh, if you're working on a small project, okay, well, writing this detailed schedule management plan might take more than the project itself. So maybe you wouldn't have a formal schedule management plan per se. Okay. Also, you might be working in an organization, again, where you do these kind of projects all the time. So, what would be in your schedule management plan? Well, what was in the last one? Okay. it might just be a copy of the last one that you had, or it might point to um, kind of standard procedures that are already documented for the organization. So it just because uh, we read these things and they seem formal and sometimes kind of daunting doesn't mean that they can't be taken care of in a straightforward way. Um, so we're going to identify the scheduling methodology and tools used to create the schedule model. We need release and iteration length or time boxed periods if we're doing time boxing in some kind of an agile approach. The level of accuracy required for activity duration estimates, unit of measures such as staff hours, days, or weeks, links to organizational procedures. Again, some of this could just be standard stuff for our organization. Project schedule model maintenance, like how often are we going to update uh, the model? Are we going to do it every day? Probably not. Every week? Maybe. Every 2 weeks? Maybe. Every month? Definitely. Control thresholds for monitoring schedule performance, such as the percentage deviation from the baseline plan. So, one question that comes up is uh, when have things changed enough that we need to revise the plan and come up with a new set of expectations and maybe get people to sign off on them again? So, this could be describing what that scenario would look like. Rules for performance measurement, especially if earned value management is used. Now, we don't talk about earned value management in this chapter specifically, but earned value management is a scheme that allows us to check the goodness of our circumstances once the project is underway. And what we essentially do is we have this concept called earned value. And every time we complete some part of the project, we take credit for what we originally thought it would cost us to produce. Okay. So if we originally thought that the whole project would cost us $1 million, and we've added up all the things we completed so far, and we originally thought that the sum of what they would cost us would be $250,000. Uh, well, we'd say that we have $250,000 of earned value. Okay. Well, we easily could have already spent a $500,000. Okay. Things might be taking us very much longer than we thought. So, earned value management is a way to tease out um, how well we're doing against a plan and figure out, are we ahead, are we behind, and find a way to figure out on the basis of how we're doing so far, what would this project cost to complete, and when do we think we'd be done? Okay, but we're not talking about the details of that quite yet. Formats and frequency for schedule reports. Okay. So again, on a big project, these are all things that people are going to want you to know, particularly if you're taking a waterfall approach. Defining activities. So an activity is a distinct scheduled portion of work performed during the course of a project. The goal of defining the defining activities process is to ensure that the project team members have a complete understanding of all work they must do as part of the project scope so that they can start scheduling the work. For example, how can you estimate how long it will take or what resources you will need to prepare a report if you don't have more detailed information on the report? So, what teams usually do is that they take the expression of the scope. Again, if we're taking a predictive or waterfall approach, we have a scope statement and we have a breakdown structure, a WBS. And the WBS is expressed in terms of the outputs that we have to produce. And now we begin to ask ourselves, what work do we have to do to produce each of those outputs? Okay, and we typically use a WBS as a way to organize the tasks. And most of the project planning tools would allow us to uh, kind of type the WBS into the project planning tool, a project planning tool like, say, Microsoft project. And then as we define activities, we will be doing it on the lowest level of the WBS so that these activities or tasks kind of hang off of the lowest of the levels of the WBS. Okay? Now, that's how people get confused and think activities are part of the WBS. Well, in project planning tools, by the time you have a full project plan, uh, you have the activities or tasks hanging off of the bottom of the WBS. And one of the most powerful aspects of the WBS is it's supposed to help the team that's doing the planning brainstorm about all the activities that need to be done in order to get the project done. Because again, anything we've promised is part of the WBS. That includes actual parts of the product or service and deliverables that are part of the project management process. Okay. So at least in theory, there's nothing we promise to anybody that's not in the WBS. So if we subsequently get into this defining activities, and we define all the activities that we need to produce those outputs, then that's exhaustively what needs to be done to get the project done. Okay. Now, I am going to put a footnote here and say there are parts of a work process that teams do that sometimes are not in the project plan exactly. They're not, for instance, where do you put the weekly meetings? Okay. Uh, where do you put training? Where do you put things that team members are going to do that are not directly attributable to some deliverable or other? A lot of times we call these overhead. Okay, so these are kind of enabling work that it's important for workers to do, right? But are not directly attributable to one task or other. Okay, and that's something that one has to take into account. For instance, when one is calculating the budget, okay, one also has to take that into account when scheduling activities because, for instance, if typical team members work 40 hours a week, okay, and they have 2 hours of meetings, maybe that's too much. Maybe there's an hour of meetings, and maybe there's 1 hour of recording information about their progress on the project. Okay. So, do they really work 40 hours in the week? Do they work 5 8-hour days? Or do they work 38 hours in a week? In some organizations, they only work 35 hours a week. Okay, so these are important parts of information, but normally the activities are direct activities that are going to produce the outputs that are in the WBS, and they don't include some overhead. And so when calculating the cost and when scheduling things, we need to take those other overhead activities and costs into account to make sure that we get a realistic schedule and we get a realistic budget. So, creating the activity list and attributes, activity list, a tabulation of activities to be included on a project schedule, should include an activity name, an activity identifier or number. A lot of times the project management tool would maybe generate that ID or number for you. A brief description of the activity. I've got to say that for groups of people who do the same kinds of projects all the time, uh, it might just be the activity name that describes the activity. Okay. The activity attributes provide schedule related information about each activity, such as predecessors, successors, logical relationships, leads and lags, resource requirements, constraints, imposed dates, and assumptions related to that activity. Um, so we're going to get into all those things in a couple of minutes, but so when you would be coming up with an activity list, you would jot in any information that you would need to create the schedule, mm, yeah, the network diagram. Okay, and again, we'll talk about that in a couple of minutes. Uh, Both should be in agreement with the WBS and the WBS dictionary and be reviewed by key project stakeholders. Okay, so again, I suggested that we organize this using the WBS. Okay, and in terms of this being reviewed by key project stakeholders, well, um, one important thing that people talk about a lot. Sometimes when people are talking about the project team, they don't talk about them as being stakeholders, but in a technical sense, they are. A lot of people think that you're going to come up with a good plan if the people who are going to do the work help to plan the work. So certainly people who are going to pay for the project needs to sign off on the aggregate cost of things and the time it's going to take and all that. But it's important that plans be put together by people who are going to have to do the work, because later on when you give them the work to be done and you tell them when you expect it to be done by, if they have no buy-in, well, they're less likely to meet the goals. Um, so the WBS 100% rule, when a deliverable is decomposed into smaller deliverables and eventually work packages, okay, work packages are the smallest division of deliverable stuff that we're going to do. All work required for a deliverable is included in its sub deliverables, known as the WBS 100% rule. So again, if we have a proper WBS, it should exhaustively describe everything that we're promising to deliver. Okay, that's really going to help us because we're going to be hanging our activities or tasks off of these bottom level things, which are also called work packages. And that kind of makes sense because they're going to serve as the the organizing point for the tasks or activities that we're going to be doing. So here's a work package. Report on pilot course. Okay. And here are all the activities that would go into it. And I'm not going to read them all, but this is 10 activities that we're expecting that it's going to take to deliver the report on the pilot course. Okay. And the last one, distribute final report. Okay. And if you look at them, they're pretty good. They should do a pretty good job of describing a plan to get the work done. And then the very last thing is typically distribute, review, deliver, ship, something like that. Okay. This is a sample activity list and attributes, and I don't like this. Okay. Most people like to organize these things using electronic tools, and an activity list with attributes would be would naturally be a good thing for something like um, an electronic spreadsheet or a table in a relational database. One problem that we have is we have these assumptions notes that seem to go on and on. Okay. So that doesn't lead to such a great uh, layout for a table. But these things should be organized into a table. Okay. Perhaps that's not a good thing to turn into a slide. Now, milestones. Milestones are something you may hear people talk about with regard to projects, and they're a really important idea. So, a milestone is a significant point or event in a project. It often takes several activities and a lot of work to complete a milestone, but the milestone itself is like a marker to help identify necessary activities. So it's a point in time, okay? Uh, there is usually no cost or duration for a milestone, which is to say that when people put milestones into project planning tools, they typically place them after the last piece of work that had to be done to reach the milestone. So let's go back 2 slides, okay? And let's say that there was a milestone after the report on the pilot course, okay? Instead of making the milestone the distribute final report activity for report on pilot course, we would create another activity, okay, and we wouldn't give it any duration itself, but we would say it could only be done after this activity was done, okay, and we would say it's the milestone um, pilot course complete. Okay, so implicitly we're saying that the pilot course is complete when all these things are done for the report on the pilot course. Okay. Um, so milestones are usually put into project planning tools as a task that has no cost or duration. It just has a placement. It can only We can only get to it when all the right things are already done. Okay. Project sponsors and senior managers often focus on major milestones when reviewing projects. Okay, because they can't always focus on every activity. So this is a subset. Okay. Sample milestones for many projects include sign off on key documents, completion of specific products, completion of important process related work, such as awarding a contract to a supplier. I often say that a good test for what would be a good milestone is it celebration worthy? Okay. And my classic project celebration is a pizza party. Okay. So is this significant enough that we would schedule a party? We're all going to go out and have, say, pizza and beer and soft drinks if we're not drinkers. And we're going to have a party and celebrate that we've achieved the milestone. Now, if it seems like it's not pizza party worthy, then maybe it's not big enough to be a milestone. Okay. So that's it. This is the kind of stuff that uh, wide groups of people associated with a project are energized by the fact that we've gotten to the milestone. So here's a sample milestone list. I think this is having to do with the case project from the book. Draft survey completed, survey comments submitted, survey sent out by IT, percentage of survey respondents reviewed. I guess it was a particular percentage, like 75% or something. Survey report completed, survey results reported to steering committee. Okay. Now, this is a whole lot of things. Again, the more celebrations you have, the less each one is worth, right? So um, maybe this is a lot of milestones for a project this small. I don't know. It seems like a lot to me. Okay, so how do you pick a milestone? Well, the first thing they do, and this has been hanging around formal project management for a long time. They have an acronym for the properties that a milestone event should have. It should be smart, measurable, assignable, realistic, time framed. Now, I have a resistance to these words that are built on the first letter of each of the uh, of the component words. Specific, yeah, well, yeah. Measurable, yeah. Assignable, okay. Somebody has the responsibility to see that we achieve the milestone, I guess. Realistic, okay. If it's not realistic, then it's a pretty bad milestone. And time framed, well, it has a date on the schedule, okay. Now, apart from the fact that I have a resistance to these kinds of acronyms, I think these are all kind of sensible ideas. You can also use milestones to help reduce schedule risk by following these best practices. Define the milestones early in the project and include them in a Gantt chart to provide a visual guide. Again, a Gantt chart is a mapping of the activities in your project over the calendar. Okay. Keep milestones small and frequent. Well, that's what they believe. I think they ought to be a little bit bigger and uh, again, if they're not pizza party worthy, I don't want to be bothered personally. Uh, the set of milestones must be all encompassing. Okay. Each milestone must be binary, meaning it is either a complete or incomplete. Again, since it's typical for us to not put work into milestones, it's either achieved or not achieved. The thing that's either complete or incomplete is whatever came before it on the schedule. Uh, Carefully monitor the milestones on the critical path. Now, we haven't gotten to critical path yet, so believe me, this is a good thing to do. Okay, so once we've identified the activities and we know their properties, okay, now we can sequence them, okay? Uh, Sequencing activities involves reviewing the activity list and attributes, the project scope statement, and milestone list to determine the relationships or dependencies between activities. A dependency relationship relates to the sequencing of project activities or tasks. For example, does a certain activity have to be finished before another one can start? Now, this is called a finish to start dependency, and it's the most common uh, dependency in all of project scheduling. We have activity A and we have activity B, and activity A has to finish before activity B can start. So that's a finish to start dependency. Can the project team do several activities in parallel? Okay. Now, normally when you use these project planning tools, um, the first thing that you do, the first version of the schedule that you have, you identify everything that could be done in parallel in some kind of ideal world where you had infinite resources. Okay, what do we mean by that? Well, let's talk about a software development project, okay? And we have a lot of programs that have to be written. Let's say we have 100 programs that have to be written, okay? And we've got 4 programmers, okay? Now, it, there's probably some dependencies amongst the programs that means that we should want to have some done before we do others. And let's say they fall into 4 groups, okay? All right. So, uh, still, if we do, if we divide 100 by 4, there are 25 that can be done at one time. Okay. Can we do them at the same time? We call that in parallel rather than in sequence. We talk about parallel and sequence for these things. It's the same kind of thing that people talk about in like electrical and electronic diagrams. Okay. Well, uh, do we have 25 programmers? No, we probably don't. We probably have 5 or 4 or 3 or 10 or something like that. But normally, when we're doing these activity diagramming things, uh, we're not taking our we're not taking our staffing into account. So if we have 25 things that can be done in parallel with each other, we normally diagram such that it looks like they can all be done at the same time. Most project planning tools, and again, the one that I've used the most is a Microsoft project. They allow you to later go back and define the the resources that each activity takes and what your pool of resources are. And then they have a process where the schedule will be stretched out such that you don't violate any of your resource constraints. It never makes the schedule go faster. It always makes it go slower. Okay. So typically, when we're defining the dependencies, we're defining the ones that uh, we have to finish A before we start B, not because we don't have enough staff to do B, but because according to the way that we work on our project, we believe that tasks like A need to be finished before we start tasks like B, without regard to workload and staffing. Okay. Can the project team do several activities in parallel? Often, yes. Can some overlap? Okay. Um, what a lot of people will do is they'll say no, that they can't overlap. And in the method that I'm going to show you for calculating schedules, it assumes that they can't overlap. But in project planning software, like again, the kind of budget version of that is something like a Microsoft project. You can either you can say that things have leads, which means they can start early, or you can say they have lags. That means that they have to start after some delay. Sequence activities has a different impact on developing and managing a project. Oh, has a significant impact on developing and managing the project's schedule. So even though it doesn't say it here, but I've implied it in my comments, um, uh, generally speaking, the scheduling using scheduling tools goes in two waves. Okay. Wave one, you don't take resource constraints into account and you come up with some kind of idealized schedule that says, if I had all the workers in the world and I had all the machines in the world and I had all of the tools in the world, then how long would it take to do the project? Okay. Okay. So that'll give you a date. Okay. It's not realistic, but it's never going to be faster than that. And then typically you put more information into the tool about what kind of resources you have and what kind of resources are going to be used by each activity. And it goes through and it delays activities until there's enough resources for them to start. That pushes the schedule out later. Okay. And that's usually version 2 of the schedule. Okay. Now, we're not going to do that in the things that we practice in this course, at least in the semester that I'm recording this, because that's a kind of a level 2 schedule planning skill that we're not going to do. So let's talk about the dependencies amongst these activities or tasks. Okay, we have mandatory dependencies as contrasted with discretionary dependencies. We have external dependencies as contrasted with internal dependencies. Okay, so let's look at the first division. Mandatory dependencies are inherent in the nature of the work being performed on the project. We definitely need to get those. For instance, you cannot hold training classes until the training materials are ready. Discretionary dependencies are defined by the project team. A project team might follow a good practice and not start a detailed design work until the stakeholders sign off on all the analysis work. Okay. So, why? Well, because they might not sign off and we might have to change it. Let's look at Division 2, external versus internal. External dependencies involve relationships between project and non-project activities. And by project, we mean controlled by our team in our project plan. Okay. By non-project, we mean controlled by some other team or organization, not in our project plan, not under our direct control. So the installation of new software might depend on delivery of new hardware from an external supplier. Even though the delivery of the new hardware might not be in the scope of the project, it should have an external dependency added to it because delivery of the hardware will affect the project schedule. Then internal dependencies are within the project team's control, such as testing a machine that must be assembled where all the work is done inside the team. Internal dependencies should be not in our plan. External, I'm sorry, internal dependencies should all be in our plan, and all the work should be in our plan too. External dependencies, they're a way to put things into modern project planning tools where you can say, um, geez, it's almost the opposite of a milestone. You can have a you can have a you can have a task that's really being done by some other team, some other organization, and you can put that in the schedule so that it does influence your schedule, but the work is not yours. It's all somebody else's. So again, these modern project scheduling teams allow you to give that some kind of a date, okay? And if the date in which you're going to get the new machine is going to change, well, you can change that in your scheduling system and you can see what the potential impacts are. Network diagrams. Okay, let's look at a network diagram before we try to talk about it. Here's one on the next slide. Okay, so this is a kind of a network a diagram that's used for schedule calculations. This one is called activity on arrow. That's the technique that's being used. That's the technique that I'm teaching you and that you're going to use in your practice assignment. Okay. Um, so it's called activity on arrow because the activities or the tasks are these arrows. So here's activity A, here's activity B, here's activity C. Okay. Uh, when we say A equal 10, we say the duration of activity A is 10 days. B equals 5, the duration of activity B is 5 days. Okay. What are these numbered circles? They're called nodes, and it's how we express the dependencies. Okay. So let's see this. The first node is right at the start of the project, and as soon as you start your project, you can start A and B. Okay, they're not depending on anything but the project having been started. Okay, but let's look at activity C. Okay, when can it start? It can start when activity A is done. That's what it takes to get to 2 and satisfy all the requirements. Okay, D could start then too. Uh, what about activity E? Well, to start activity E, B has to be done and C has to be done, and to start C, A has to be done. Okay, so these nodes, as we call them, are, we connect the arrows to express the dependencies. Okay, and so the objective is to get to the end. So when we get to node 7, we're done. Okay, and we need to do everything in here. So this isn't, Schwalbe says in the book at one point, this isn't a race to get to the end, and when we get to the end, we stop the work on everything else. We have to get everything done. This is a way for us to predict how early we might finish. Okay? Okay, so this is a network diagram. Okay, now, do people use these in the field? Largely no. Okay, people use tools that are based on the algorithms that we're going to learn on how to calculate the days. Okay, so if you want to understand how project scheduling gets done by modern project scheduling tools, the the simple example of which would be Microsoft Project. Well, you have to understand this kind of algorithm. Okay. Uh, do we draw these diagrams and calculate them by hand? No. Did I personally do this in my career? Yes. Okay. So these kind of, again, you can buy a copy of Microsoft Project now for, I don't know, $250, $350. Okay. When I was an early project manager doing software development projects, um, in order to get software that did that, you'd have to buy a mini computer that cost maybe $50,000. And you'd have to buy a software package that costs maybe another $35,000. So you would have had to have spent $85,000. Now, you could do a lot of projects with that. But my projects, we didn't have anything like that. We drew these diagrams and we did the calculations. And one of my earliest PC projects was to write a program that in which I typed in all these things from the diagram and it ran things and gave the answers. Okay. So, do practitioners do this kind of work now? No. Did they do it uh, in 1980? Yeah, they did. At least I did. Were there people on projects that had software to do that? Yeah, in 1980, there were people who worked for, say, government contractors and stuff who had software that did this. But you didn't buy it for 250 or $300. You bought it for like 100,000 bucks. And 100,000 bucks was a lot of money then, right? So, we teach you this approach so that you understand how it works. Okay, we don't expect you to do it by hand on the job. We would expect you to use tools that use these kinds of algorithms. Okay, so let's back up a bit. Network diagrams are the preferred technique for showing activity sequencing. A network diagram is a schematic display of the logical relationships among or the sequencing of project activities. There are two um, there are two expressions of this. The one that we just saw is called activity on arrow or arrow diagramming method at AOA or ADM. Activities are represented by arrows and connected at points called nodes to illustrate the sequences of activities. We only show finished to start dependencies. It's the most common type. So this is the kind of diagram that's usually used to teach students how to do uh, scheduling using activity diagrams. Okay. There's another method called the precedence diagramming method, and I'll show you what that looks like in a chart in a second. It's also called activity on nodes because the nodes are the activities or tasks, and the arrows are the dependencies. So they use boxes for the nodes, uh, and they use the arrows for the dependency types. So again, this is activity on arrow. That's what we're going to practice. And let's find an activity on. Here is a precedence diagram. Okay, so you can't really read this well, but these are the boxes are the tasks or the activities, and we draw the arrows in order to express the dependencies. Now, we can express more dependencies in this kind of a chart than we can in activity on arrow. So if you're asked yourself, do, do modern project scheduling systems use activity on arrow or precedence diagramming? Well, if you were to take their kind of computational model and you were to visualize it, which you typically can, you can say draw the diagram, you would get this precedence diagramming uh, method. Are these easy to calculate? Well, these are easy to calculate if you only have start to finish dependencies, and that's all we have here, okay? They're challenging to calculate by hand if you have some of the other dependencies, and we'll talk about what those are, okay? So people only really do by hand when they're learning. They only do this kind of thing that we're going to do, okay? That the other things are not easily done by hand, okay? All right. More on network diagrams. Keep in mind that the diagram represents activities that must be done to complete the project. It's not a race to get from the first node to the last. We have to do it all. Every activity on the diagram must be completed for the project to finish. Not every item on the WBS needs to be on the network diagram. Only activities with dependencies need to be shown on the network diagram. Now that's just to say it's possible to simplify diagrams. Okay, how could you simplify a diagram? Um, hmm. You could take a series of nodes, and you could take a sense. You could take a series of activities and you could kind of cut out something if you could calculate its impact. Okay. Generally speaking, when you're doing these by hand, you put everything in. Okay. So even though they said not, um, we're going to do everyone. Uh, Steps for creating an activity on our network diagram. Find all the activities that start at node 1, draw their finish nodes, and draw arrows between node 1 and the finish nodes. Put the activity letter or name on the associated arrow. The good thing about letters or codes is they fit on the arrow well. If you have a duration estimate, write that next to the activity letter or name. Okay, so what did we do? We said A equals 10. That's the duration, okay, in workdays, okay? Typically, it's in workdays. So let's say we work 5-day weeks. Let's say A equals 10, okay? So we work Monday through Friday. We have Saturday, Sunday off. We work Monday through Friday. Implicitly, we're expecting this to take 2 full work weeks. Okay. Where were we? Continue drawing the network diagram, working from left to right, looking for bursts and merges. Bursts occur when 2 or more activities follow a single node. A merge occurs when 2 or more activities precede a single node. Okay, bursts. Where's bursts? No, we don't have it here. Well, we'll get to it. We'll show you a burst. Okay, so this is a burst. Okay, after 2, it bursts into 2 activities. So after 2, we have a burst. Okay. After 4, we have a burst. Okay. Where do we have a merge? We have a merge into 3. Okay. We have a merge into 4. Okay. Um, we have a merge into 7. Okay. That's bursts and merges. Continue drawing the network diagram until all activities with dependencies are included on the diagram. As a rule of thumb, all arrowheads should face toward the right, and no arrows should cross on the network diagram. You might need to redraw the diagram to make it look presentable. This can be challenging, okay? Because, well, you start to draw these things and they get challenging. Now, typically, you can get these project planning software tools to draw a diagram for you, and the software is pretty good at drawing them without getting the lines to cross. Okay. Again, they typically look like that. Okay, but here's a line that crosses, right? Right here. Here's a line that crosses. Okay, so it can be challenging. When I used to draw these activity on arrow diagrams by hand, there was a lot of erasing going on. That's all I can say. We used to do them, I used to do them on these acetate sheets that were very easy to erase and very expensive to buy. We buy them at places like Dick Blick and places like that that would sell these things to uh, for uh, drafting and design. Um, so let's talk about the differences between activity on arrow versus activity on node. Now, let's say this. Very few people draw activity on node diagrams by hand. Okay. And most project planning software is based on a computing model that's based on activity on node. Okay. That said, most project plans could be expressed in terms of activity on arrow. Okay, most of the dependencies between activities are finished to start, which can be expressed on activity on arrow. Okay, so um, activity on arrow, great for learning. Activity on node is what really it powers these planning software tools. Um, do most practitioners use all of the capability in the software tools that is sort of inherent in activity on node and all the dependencies that you can express? No, they don't. So let's look at this. Distinguishing factor, line information on activity on arrow, it's the activities. Um, and the precedence. Activity on nodes, the line represents the precedence. The node shape is a circle on activity on arrow. It's a box on activity on node. Activity information. Uh, you only have room for like the name and the duration of the activity, where typically on activity on node with the box, you've got room for more things. Okay. The line shape in activity on arrow is straight lines. On activity on node, it uses right angles. Again, we curved we curve the right angles. The line directions always moves rightward because it's all finished to start. In an activity on node, it can move backwards depending upon other relationships. Okay, the one that we've talked about so far is this FS, finish to start. We can have a finish to finish, a start to finish, a start to start. The default and the way most people think of dependencies in projects is this FS, finish to start. And talking about activity dependencies, here are here are some summary things that look like they came right out of Microsoft projects. I wouldn't be surprised if they did. So, if finish to start, it typically abbreviated as FS. Task B can't start until task A is done. Okay, this is the default link type in project, and when they say that, they mean Microsoft project, which is why I think this came out of here. Okay, start to start. Task B can't start until task A starts. They don't have to start at the same time. Task B can begin anytime after task A begins. Finish to finish. Task B can't finish until task A is done. They don't have to end at the same time. Task B can end any time after task A ends. And then start to finish. Task B can't finish until task A begins. Okay, so most of us who do project planning using these kinds of tools, we model almost everything that we do with the default finish to start. Okay, roughly it does a good job. Okay, these other kinds of things, there are people who are using these kind of tools, for instance, um, to plan out things like complex surgeries, okay, organ transplants, um, separating conjoined twins, things like that. They could easily have a lot of very complex relationships in terms of the activities and tasks. But for normal run of the mill IT stuff, finish to start works pretty well for most things. Okay. Here's our precedence diagram. Lead and lag. Okay. So let's go back to activity on arrow. Okay. Activities on arrow, once it's okay to start, okay, for here for D. Once A is done, we can start D and we can start C right away, okay? And we can't start either D or C until A is done, okay? So these rules are inflexible. It's possible with more sophisticated versions, typically based upon these activity on node systems. It's possible to give activities these things called leads and lags. It's not, they're not easily expressed on activity on arrow diagrams. So here are sort of examples of leads and lags from the case in the book. Kristen and her team reviewed all the project activities and determined which ones had dependencies. They also determined which activities had lag time or required a gap in time and which ones had lead time, which could be overlapped. Okay. For example, you might want to wait a certain period of time, perhaps 30 days after holding the first training class before holding the second one, a lag of 30 days. Or you might want to get started on writing a long research report 5 days before all of your reference materials are gathered. A lead of 5 days. Okay. So, in these tools, Microsoft Project being a very popular and affordable one that's based on activity on node, one can express leads or lags for any one of the activities. Okay. Activity duration estimating. Duration includes the actual amount of time spent working on an activity plus elapsed time. I think I always want to say plus other elapsed time. Okay. I always I think the last version of her slides that I had, which is from another line of textbooks that she has, I actually changed the slide to say other elapsed time. For example, even though it would take one work week or 5 work days to do the actual work, the duration estimate might be 2 weeks to allow extra time needed to obtain outside information or allow for resource availability. Okay, so we're trying to figure out how many work days, that doesn't include scheduled days off, how many work days it would take. Okay, so that's time spent working plus other elapsed time. Effort is the number of work days or work hours required to complete a task. A duration estimate of 1 day could be based on 8 hours of work or 80 hours of work. Okay, so this is potentially confusing. Okay, so when we're trying to figure out duration, okay, we are asking ourselves this. Given the kind of resources we normally give to this activity, like one programmer, okay, what would the duration be? Okay, so we typically estimate duration and effort at the same time. Okay, so let's say that we thought that this could be done by, let's not talk about programmers because programs with two people are sometimes challenging to write. But let's say we were painting, okay? And let's say the activity was to paint the north wall of Kevin's house, okay? We could say that the duration is 1 day, okay? The effort is 16 hours. Okay, implicit in that is that we're expecting two painters to work that. Okay. So these have a relationship to each other. Okay. We might come back and say, what if we had 4 painters? Could it be done in 4 hours? Probably not. Probably whatever we put in the schedule is the most is our typical staffing for this, right? All right. The other thing is how many hours are we talking about? Okay. Painters typically work 8-hour days, I would assume. Uh, if they have some kind of a meeting to go over the work, that's usually included in their work. If their supervisor comes by at sort of 8 a.m. when they start and they have a little pep talk and they look at the job, they charge that to painting the north wall. Okay? This is sort of unlike programming teams who even some kind of agile programming team might have a stand-up agile scrum once per week. Maybe that takes a half hour or maybe it takes an hour. Okay. What are they going to charge that to? Okay. Also, if the programmer has to sit down once a week and fill out their timesheet in order to say what things they work on, well, what are they going to charge that to? Maybe a typical programmer doesn't work 40 hours a week. Maybe they work 37 and a half or whatever. So, whatever our typical work day is, that's what we're estimating this in terms of. Okay, if typically we charge out uh, 7.5 hours to tasks, and we're going to put two people on it, uh, we would say that this thing would take 7.5 hours, uh, and the effort would be 15. Okay, or if we're working in round eights, we would say it would take 8 hours and the effort would be 16. Okay, see, the duration is used to determine the schedule, and the effort is used to determine the labor costs. And what's interesting is these planning tools, and the one that I've used the most is Microsoft Project. They give you opportunities to go back and shift these. Okay. Okay. So there is a relationship between these two, and if you're really good at it, you can say, okay, I'm not going to have two people, and so it'll take this effort of 16 hours and go, oh, now the duration is going to be 16, right? So that's one of the Microsoft Project features that I find the most frustrating is the magic that goes on when you begin to change these numbers. It wants to change the other one in some kind of a way that's always not completely clear to me. But it'll be clear to you because you'll be better than me. Uh, so a question comes up. Do we just want regular duration estimates, or do we want some kind of statistical approach? Okay, let me give you the short answer. It's hard enough to get regular duration estimates. Okay, the statistical approaches require you to collect more data. Okay, in my experience, you don't always get better answers. It's hard enough to get one set of estimates out of your team. Okay. Uh, so regular duration estimates are provided as discrete one number estimates like 4 weeks. A range estimate might be between 3 and 5 weeks. Now, what what's the most likely? We don't know. There's a 3 point estimate system that we'll see in a slide or two called PERT. PERT standing for Program Evaluation and Review Technique. It's been around since the 1950s, in which we come up with three estimates: an optimistic one, a most likely one, and a pessimistic one. And PERT has a formula for figuring that out. I'll tell you, as in my experience in doing software projects, it's hard enough to get duration estimates, and then the more the more you try to collect, the harder it gets. I mean, you're going to do this for every task you have. Okay. Now, there are people who would say that my opinion on that is cynical, but we'll have to see. Oh, here's PERT right here. So how do you turn three numbers into one value? Well, they have a formula that would be expressed well here if there were a few more parentheses. You collect three values: the optimistic, the most likely, and the pessimistic. And you take 1 times optimistic plus 4 times most likely plus pessimistic times 1. Okay, so that's 1 plus 4, that's 5, plus 1, that's 6 over 6. So this is a weighted average where the most likely time has 4 times the weight, and the optimistic and the pessimistic make up the other two. Okay? Again, it was an interesting idea. It's been around since the 1950s. I'm sure some people still use it. Okay? In my experience, it was hard enough to get one value. Now, you can use Monte Carlo simulation, which means you'll just you'll come up with a point estimate, and then you'll describe the statistical distribution associated with that. So to perform a Monte Carlo simulation, in addition to the 3-point estimate, you also collect probabilistic information for each activity and duration estimate. For example, estimators must provide a probability of each activity being completed between the optimistic and the most likely times. Then they run a computer simulation to find probability distributions. Okay, so not only would you have to come up with 3 points, but you'd have to come up with probabilities as well. Okay, now I think there probably are some projects in which these more probabilistic kinds of things are useful. Um, they're not your run-of-the-mill software project. Okay, they might be a project to get somebody to Mars. Okay, all right. There might be a project to develop a new technology around nuclear fusion. Okay? There's a lot we don't know about nuclear fusion. Okay? There are some people who think we should already have uh, um, power technology based upon nuclear fusion. There's some people who believe that we're very close to it and we're going to have it in just a year or 2 or 4 or 5. And there's some people who believe that we're never going to get to it. There's a 3-point distribution for you. Sample activity duration estimates. So this is from the case. Kristen and her team decided to enter realistic discrete estimates for each activity instead of using PERT or a Monte Carlo simulation. I would say that's more typical. She stressed that people who would do the work should provide the estimate. We talked about that before. And they should have 50% confidence in meeting each estimate. Now, this is interesting because what we're looking for is estimates that are going to be true on average. Okay? So sometimes we're going to come in early. Sometimes we're going to come in late. But we would like estimates that, in the aggregate are going to be correct. So that's why she said 50% confidence. Um, This is an interesting cartoon because it's making fun of the kind of estimates that you get from software products about how long they're going to take to download and how long that they're going to take to install. Okay. And at one point they say it's 15 minutes, and then they say it's 6 days, and then they say it's 30 seconds. And they tend to jump around a lot because they're not very sophisticated by modern things. I would I, I would say that the state of the art in terms of calculating how long something will take is being pushed by applications like automobile navigation systems. Like I use my Apple iPhone to navigate for the trip that I take from my home in Glenview, which is a Chicago suburb, to Champaign, and once a week, and then when I come back a day or two later, I do the same thing. And it is pretty good at telling me exactly how long it's going to take. And I think it probably uses a machine learning model. There's certainly things that we're not talking about doing uh, here. But there are technologies that don't jump around. Like I'll get on the road and it'll tell me I'm getting home at well, if I leave at 5 p.m., I get on Tuesday, I get home at like 8 o'clock at night, and it'll tell me it's not really good at knowing whether I'm going to stop for gas, which can take me up to a half hour. So it'll typically tell me that I'm going to get home at 7:30, 2.5 hours, and I know I'm going to stop for gas, and I just add a half hour onto that, and pretty much it's pretty good. It does not jump around. So um, modern statistical methods of estimating how long something will take are getting better. I don't not sure we're really using them in project management yet. Perhaps we will be soon. And this cartoon is about sort of approaches to, to estimating how long things will take that have come and gone. I mean, we may still have to suffer through them, but they've come and gone. Developing the project schedule. So, schedule development uses the results of all the preceding project time management processes to determine the start and end dates of the project activities and of the entire project. The zoning project schedule is often shown on a Gantt chart. Okay, a standard format for displaying the project schedule uh, by listing activities and their corresponding start and finish dates in a calendar format. So let's go find a Gantt chart. Here's a Gantt chart. It's drawn by Microsoft Project. Okay, so here we took a bunch of activities, probably from that activity on arrow diagram that we had. And so we have the name, we have the duration, and then it just shows the activities um, as bars. Okay. You'll notice we also see these arrows. Okay. Now, Gantt charts have been around for a long time, like 100 years, long time. Gantt, um, Gantt may have been around. I may be exaggerating, but he may be from the 1880s. Okay, so Gantt charts have been around a long time. This practice of showing these dependency arrows got into project management planning software in the 1990s or something like that, late 1980s. Okay, it's a standard feature now, but it's not a Gantt chart feature. It's a feature of these products. So you might want to look at this as a Microsoft project annotated Gantt chart, because officially, true Gantt charts that Gantt invented eons ago didn't have these. Okay, so that's what we mean when we say Gantt chart. The ultimate goal of schedule development is to create a realistic project schedule that provides a basis for monitoring project progress for the time uh, uh, dimension of the project. Okay, now I just want to say here, and I've talked about it before, but I'm just going to leave a footnote that says that the kind of the kind of schedule that we've got here is the kind of schedule that you get if you express your days, you express your durations in terms of your typical staffing, okay? And you've got staffing to cover that, right? Okay. So this will get, in that case, you'll get a realistic schedule, okay? If it turns out that you have a lot of parallel activities, like you have a batch of 100 programs that have to be written, okay, and you don't express the dependencies of trying to staff that in your project planning tool, then it's going to schedule one under the other, under the other, under the other, under the other, under the other. And the first version of a schedule that you're going to get is going to be a hypothetical, idealized schedule that would be the schedule that you would get if you had 100 programmers. Okay? And then you've got to go back and tell it you don't have 100 programmers. Okay? Which takes you some effort, right? And we're not going to go through how one would do that, but you can do it. You tell it what kind of resources you have and what kind of resources each of these activities uses. And then you ask it to level the schedule, okay? And then it goes through and it pushes things out to the right, okay? Why pushes them to the right? Well, you push them to right, it makes them later, okay? Why later? Well, you have to wait for somebody to become available to take that task, so that when you go through and give realistic resources to a project planning tool and you ask it to level the schedule, nothing ever gets earlier. Nothing on the Gantt chart ever moves back to the left. It only gets pushed out to the right. Okay? So if in that kind of project you go through this subsequent phase and you level the schedule, it could double the time. It could triple the time. Okay? Especially if your schedule is showing like all your programs being written in week one by your theoretically 100 programmers that you don't have. Okay? Now that's the way people do it. Okay? They put the real dependencies into the schedule on the basis of uh, how this could be done with infinite resources. Then they put the resources in and they level the schedule. Okay, that's a big pain in the butt to do, but it does actually work, and it pushes your schedule way out to the right. Okay, and then you get into conversations about, well, how many programmers do you need? It's like, well, you've given me 3 and we're getting done in 3 years. Maybe you've got to give me a few more, right? So now, having said that, I'll move on to critical path analysis. At some point, okay, you figure out your staffing and you level your schedule, okay, and you have a schedule. And so now, based upon the schedule and based upon the relationships of the activities, and using something called CPM, critical path method, you can do this thing called a critical path analysis, which is really insightful and useful to project managers. So CPM is a network diagramming technique used to predict total project duration. Okay. And when we say diagramming, we mean that it can be used by calculating on the diagram, or it could actually be used by some planning tool that's based upon that same algorithmic approach. So a critical path for a project is the series of activities that determine the earliest time by which the project can be completed. It's the longest path through the network diagram, and it has the least amount of slack or float. Now, we haven't said what slack or float are. Slack or float, these are two terms that essentially mean the same thing, is the amount of time an activity may be delayed without delaying a succeeding activity or the project finish date. So we're saying at this point in the schedule, how much extra time that I have? Some of these things that are not on the critical path, well, you could delay them a bit and they wouldn't affect, they wouldn't make the project later. Okay. One kind of fine nuance is, uh, will they make any activity later? Uh, or uh, they may make some activity later, but they might not make the project later. So there are different kinds of slack and float that they talk about. The longest path, or the path containing the critical task, is what's driving the completion a date for the project. So here, and this is what we're going to learn how to do when we do our calculations. You take an activity on arrow diagram and you can calculate how long it takes you to get down each path. Now, I want to remind you, this isn't a race, right? We have to complete all the paths. Okay. So we're less interested in the shortest path. Okay. Those are people who get to the finish line first. We're interested in the longest path, where if this were a foot race, we would be interested who's the last person on our team to finish the course and when are they going to finish. Okay, because everybody on the team has to finish before we're done with the race, if you're going to think of it in race terms. Okay, so that takes into account the durations and the dependencies. So here's one way to analyze it. They've added up these paths, and the longest one is 37. Okay, and that's ACEFH. So ACEFH. That takes 37 days. Okay, so the minimum duration of this project is 37 days. The critical path, the sequence of activities that make up that path, is ACEFH. Sometimes you'll see that highlighted in some color. Okay. And that's the longest path through the project, but it's the shortest possible time in which the project can be completed. Because again, if you're thinking of it as like a cross-country meet or something like that, that's the time when our last person crosses the finish line. Okay, and that's when our team's done. Okay. What does critical path really mean? Critical path shows the shortest time in which a project can be completed. If one or more activities on the critical path takes longer than planned, the whole project schedule will slip unless the project manager takes corrective action. So unless the project manager takes corrective action, this is where we have the hook that potentially could sell you on understanding critical path and using it. For example, Apple Computer Team members put a stuffed gorilla on top of the cubicle of whoever was in charge of a critical task so they would not distract him or her. So a lot of times nobody knows what's on the critical path and they go bother people who are on the critical path. Well, that's not a good idea. That's going to make the whole team late. Okay? And here's the thing. We don't explicitly say it here in the slides, but the project manager does have the opportunity to change staffing, right? So here's what they could do. Let's say we have some activity on the critical path that, let's say we're worried about the critical path, right? And we need to put more people on it. Let's say it's the kind of activity like with painting. Like you could put a second painter on the north wall of Kevin's house and it'd probably get done in half the time. Okay. Could you put four? No, Kevin's house isn't that big. Could you put 10? It's definitely not that big. But you could put a second painter there. So you only have so many painters. Okay. So what are you going to take that second painter off of? Well, you look for paths, okay, that have slack or a float. And you say, well, who's working on that path? Okay, here's one that's 22 days long. That's BEGI. BEGI. Okay, and then you might say, well, let's borrow a person from over here and put them over here in order to, like, for instance, if we added another 7 days to BEGI path 6, it would only go up to 29. Okay. Well, maybe that could really help us on F. If we were painting, that could possibly bring this back to 3.5. Okay, so that's the kind of thinking that delays are not as important equally all over the project, that when you know the critical path, then you have the latitude to make strategic decisions. And as we go through a project and say some things take longer than we think, okay, we can update this so that we can know at any one point what the critical path is now, because the critical path can change. So, um, uh, it's interesting. Pretty mundane tasks can get on the critical path. A lot of times we think of a critical path, we think they're our most technologically risky activities. But here's one where here we're saying the fact that a name includes the word critical does not mean the critical path includes all critical or high risk activities. An executive from Walt Disney Imagineering explained that when they were doing the Disney Animal Kingdom theme park, growing the grass for the animals who needed grasses that were appropriate from their original habitats, that got on the critical path because it takes a long time to grow grass. Not because it was hard, it potentially could have been hard, but it just takes time to grow prairie grasses. Um, this 500-acre park required special grass, and it took years to grow. So growing grass was driving the completion date of the theme park, not what most people would think of as a critical activity. Okay, and a lot of times when you do these kinds of calculations, you'll find out that the critical path is someplace that you didn't think of. Now, when you see the numbers, it's obvious, but again, most of us think of the critical path as being the most technologically risky or politically risky, something like that. And that's not always the case. So, using critical path analysis to make schedule trade off, it's important to know that the critical path, what the critical path is throughout the life cycle of the project so the project manager can make trade offs. I talked about that. If one of the tasks on the critical path is behind schedule, should the schedule be renegotiated with stakeholders, or should more resources be allocated to other items on the critical path to make up for that time, or even that item if it has that opportunity? It's also common for project stakeholders to want to shorten project schedule estimates, so you need to know what tasks are on the critical path. You'll have people come say, look, we got to bring this in a month earlier. How can that be done? Well, people will do that, and we have names for this. So We call this schedule compression. So you calculate a reasonable schedule. Let's go back to what that looked like you know, let's say that's a reasonable schedule. And then they come back and go, we got to be done by August 2nd. And you go, why? You go, well, because the Queen's coming, or something. There's some reason that they want to move it back. Maybe it can't be done. I mean, you can tell them it can be done, but if it can't be done, it won't be done, right? So, um, there are two schedule compression techniques that people talk about. One's called crashing. Crashing is a technique for making cost and schedule trade-offs to obtain the greatest amount of schedule compression for the least incremental cost. If two critical tasks each take 2 weeks, and it will take $100 to shorten task one by a week and $1,000 to shorten task two, then shorten task one. So that's just do it the cheapest possible way. Or another approach to schedule compression is called fast tracking. It involves doing activities in parallel that you would normally do in sequence. Instead of waiting for task one to be totally finished before starting task two, start task two when task one is halfway done. Well, you could do that by putting lead times into the scheduling software. Schedule compression often backfires by causing cost, human resource, and quality problems, which lead to even longer schedules. So we mention this here not because we want to encourage you to do it, but because we think that people will ask you to do it, and that you ought to understand these terms. That doesn't, and you ought to be somewhat resistant to it, and you ought to understand the difference between crashing and fast tracking. Um, there's a really good book um, by this fellow Fred Brooks, who worked for IBM, and then he was a big player um, in the computer science department at the University of North Carolina. I think he's been long retired. And he wrote a book in the 1980s or late 1970s, probably, called The Mythical Man Month. And over the years, he updated the book, and he really talked about how, contrary to what was popular early, I believe, when you added people to software projects, they usually got later and had more problems. Now, this is one of the reasons why, if you look at what the Agile people are saying, is that we should have small teams. Okay, that we ought to do smaller projects and we ought to do them with small teams. This is just the kind of other side of that coin for that point of view. But the fact is, um, trying to speed up projects by crashing them, by fast tracking them, you know, by doing things that are not managing the scope. Okay, we didn't see any of these things, these schedule compression techniques. One way to control the schedule is to start talking about the scope that you're willing to throw overboard to make that August the 2nd a date when the Queen's coming. Okay, these two are not that. So most things that people think of in order to meet a date sooner or to meet a date that's in jeopardy uh, are not controlling the scope. And the fact is that controlling the scope is probably the most promising way to do it. And this is, again, one of the most promising things that the Agile people have. They keep saying that um, The way to manage a project is to have a backlog and only take the most important things off that backlog. And when you run out of time, you run out of time. Now, if you don't have a usable product when you run out of time, people are not going to be happy with you. But the fact is that these kind of things that we're talking about here, crashing and fast tracking, are both risk oriented. I'm going to take a pause here and I'll be right back. Okay, I'm back. So, uh, so we can be thoughtful about how we develop the schedule. Okay. And one kind of family of thoughtful adaptations that we could introduce to the schedule is part of this approach called critical chain scheduling. So it's a method of scheduling that considers a limited resources when creating a project schedule. It includes buffers to protect the project completion date. So the idea here is that we don't want to quote the date. You know, if we looked at our Gantt chart the way we saw it, okay, and I have to excuse me because I can't see the number of the slide that we're on. Okay, we're on 38. So let's go back to, yeah, let's go back here. Okay, so it looks like this is done on August 23rd. Do we want to quote August 23rd to our boss or our client? I don't think we do, okay? We know that things go wrong, and we know that people rely on promises, and so that we ought to have some kind of a buffer. Okay, how much buffer we have ought to have to do with, well, how big the project is. Okay, if you have, this is a project that looks like it's going on in 2 months. Okay, well, we can't have a 2 month buffer on a 2 month project. No, they're probably not going to accept that. But could we have a 2 month buffer on a 5 year project? Yeah, maybe we could. I don't know. So the bigger the project, the longer the buffer might be. And the other aspect is just how complex of a project is, how risky is this schedule, okay? We definitely don't want to just take the point estimate of when we're going to be done and then go promise that to everybody, okay? So let's go back to our number 38 where we were. Yeah, good. So it uses this thing called the theory of constraints, a management philosophy uh, developed by Eliyahu M. Goldratt and introduced in his book, The Goal. It attempts to minimize multitasking, which occurs when a resource works on more than one task at a time. Okay, so there's a lot of ideas here. One of them I talked about already, time buffers, so that we're not promising uh, coming in exactly on that schedule precisely. That schedule would be the uh, the critical path when the critical path ended. Okay. Another idea it has to do with multitasking. Okay, and I would say that the general thought that people had in the kind of work world up until just a couple of recent years ago was that multitasking was a good thing to do. People who were good multitaskers were good workers. Okay, and you needed to find the multitaskers and get them on your team, and the other people you wanted to stick somebody else with. Well, these folks are saying that multitasking isn't as good as people think, and I'm going to pause right here, and I'll continue in a second. Okay, I'm really back now. Apologize for that. Okay, so w- here's what they're saying is that multitasking, especially in terms of project work, is really overrated. So they they look at we've got three tasks. They each take 10 days each. So in a some kind of a software development project, these might be writing and testing some program, right? So if we do them in series and not in parallel, if we do them one, then the other, then the third, then we've got one completed in 10 days. We have two completed after 20 days. And then we have three completed after 30 days. And then if we do them multitasking, okay, uh, and we interleave them, task one is completed after 20 days. Task two is completed after 25 days, and task three is completed after 30 days. And they think that this is bad for the project, okay? And I can see the argument for that. One, there's a certain amount of overhead that goes into doing more than one thing at the same time. Two, um, uh, ideally, we're going to want to work on the riskiest things first. Okay. And we're going to want to know whether or not we were able to get that risky thing done in 10 days. So, for instance, if we go back to the prior slide, if this task one is risky, we'd like to know at the end of 10 days if it worked. Okay. Whereas here, we don't get to find out until the end of 20 days. So, in this way of thinking, it's really become, I think, the modern way to think about project work. It's that multitasking is overrated. And if you look at the approach that the agile folks have been taking, where for um, each sprint that we're doing, each project iteration, um, we pick a couple of user stories that we want to do. Okay, um, it's it's very much not multitasking. Okay, we pick just a few things to work on and we get them done. And we get them done typically, the agile people are saying a good length of a sprint is 2 weeks. Okay, and 2 weeks here would be 10 days. Okay, so I would say that the modern thinking that's coming in from these critical change scheduling folks, which who are part of the kind of predictive traditional waterfall camp, is that we ought to be working on things one at a time. And that's getting pretty close to what the Agile folks are saying. Interesting, huh? And here on slide 41, Schwalbe um, points to a couple of things that are have come out in the media that have saying that multitasking is overrated. There's an article from Forbes. Uh, Multitasking damages your brain and career. And then there's some information from the Cleveland Clinic's website that is recommending to people that they um, not try to do too much at once. Okay, so I think the tide has kind of turned on. You want the multitaskers on your team, and the reality is that the research doesn't really bear out the common wisdom that multitasking is a great thing to do. Now, let's look at another part of this critical chain scheduling, and this is, I think, where it's really brilliant. It has to do with, okay, a lot of people have said for a long time that we ought to have some kind of a schedule buffer, and we ought not look at the schedule and just promise that date at the end of it. Okay? Uh, and they have this idea. This is some of these ideas come from this critical chain scheduling, and some of these kind of predate it. But the idea here is that we ought to have some buffers, okay, and we ought to determine how big they are, kind of scientifically, and we ought to place them in the project plan strategically, okay. So a buffer is additional time to complete a task. Murphy's Law states that if something can go wrong, it will go wrong, which means that we have to plan for bad events. Parkinson's Law states that work expands to fill the time allowed. In traditional estimates, people often add a buffer to each task and use it if it's needed or not. So the the question is not, are you going to have a buffer in your schedule? The question is, where's the buffer going to be? Like, for instance, are you going to spread very thinly over every task? Are you going to tell the people who come up with your task estimates that they ought to have a buffer in every task estimate? If you remember back a couple of slides ago, we were we were summarizing what the project manager did in the case from the textbook, and she said that they ought to pick one estimate for the task and it ought to have a 50% probability, which means it should be equally likely that they came in early or they would come in late. That it was the statistical average of where they were going to be. So that's no buffer at all. Okay. And why did she want that? Well, because she wants to add the buffer. This is part of the thinking that's been around maybe longer than critical chain is scheduling. It's yeah, we need a buffer, but we don't want to build a buffer into every task or activity estimate. We want to aggregate the buffering and put it into the schedule where it's the most strategically placed. Okay? So critical chain scheduling removes the buffers from individual tasks and instead creates a project buffer or additional time added before the project's due date. That's at the end. And feeding buffers or additional time added before tasks on the critical path. Okay, so is essentially inserts some slack into the critical path because we know things will go wrong and we want the critical path to be more resilient than it naturally is. So, um, what we're doing here is we're saying that the project manager should have control over buffers. Okay. And there you go. So the critical chain goes along here, and here's a project buffer that the project manager placed at the end. Here's a feeding a buffer that's on the critical path. Here's another feeding a buffer that's on the critical path. Here's another feeding a buffer that's on the critical path. And these guys have this way of describing this as the critical chain. Okay? So I think the most important takeaway idea here is that We need buffering because of the way things happen in life. But if we allow the estimators to put a little bit of buffering into the estimates for every activity, one, human nature being what it is, people will expand the work to use that up, and then we won't have the buffer when we need it. So uh, have the project manager be in charge of the buffering. So here's a project schedule that includes a project buffer of 20 days. And that's out here. Okay. Recall that the project buffer is additional time added to the project's due date to account for unexpected factors. Kristen learned that from past projects that no matter how well you try to schedule everything, it can still be a challenge to finish on time without a mad rush at the end. So she included a buffer in the project schedule that she controlled. But she also told people to just give that point estimate. Don't pad individual estimates. She was going to pad the project promise date. Oh, here's a sample Gantt chart showing a summary tasks and milestones. So, milestones in most project planning tools, especially Microsoft Project, are these diamonds. Now, how do you get a diamond? Well, in Microsoft Project, you get a diamond by having a task that you don't assign any duration or effort to, and that marks it as a milestone, and that gives you the diamond symbol. Okay. Now, does that make it a properly chosen milestone? Is it a celebration worthy event? No, that talks about how mechanically you get Microsoft Project to produce the diamonds. We have these other things called summary tasks, and this is the way they work in Microsoft Project and most other planning tools. You'll see that this plan is organized by the PMI process groups, initiating, planning, executing, blah blah blah. And at any one time, you can summarize the Gantt chart by over in the left hand side collapsing a grouping such that all of the sub parts are collected up underneath. And this rendering that you get here, where you get a dark bar with these kind of pentagrams at the end, that's called a summary task. So that's the collection of all the individual tasks. If you clicked on the plus and got them all to drop down, they all would start to look like the tasks that we already see in the Gantt chart. But that's what a summary task is. Okay. A sample project calendar. Okay, so when we're asking a planning tool like Microsoft Project to help us schedule the project, we can tell it what the working and the non-working days are. Okay. Now, we're not going to learn how to do that, but we're going to know that these tools have these capabilities. Okay, so let's talk a bit about cost. Project cost management includes the processes required to ensure the project team completes the project within an approved budget. The main planning tasks are planning cost management, that's the plan for the planning, estimating costs and determining the budget. The main documents produced and called include a cost management plan, that's the plan for the planning activity, a cost estimate, and a cost performance baseline. Okay. The cost performance baseline is, I think, the budget. So planning cost management. Again, you're going to write out a plan for cost management if you're doing a big project. Okay. If you're doing a small project, well, maybe you might have a sentence or two at most. Or you might have a standard way that you do this in your organization all the time. So your cost management plan would be a copy of whatever you put into the last project with some editing. Possible contents of a cost management plan: units of measure, levels of precision, levels of accuracy. This is also interesting, such as we think this is going to be accurate with plus or minus 10%. Links to organizational procedures, those are things that are not in the plan, but are maybe like standard boilerplate things. Control thresholds for monitoring cost performance, such as percentage deviation from the baseline. So if we see we're over by 20%, are we going to regroup and perhaps replan? Rules for performance measurement, reporting formats and frequency of the reports, additional details about cost activities. So I don't like this slide on slide 51. It talks about how a company got funding for their project through crowdsourcing. And that's maybe an interesting way to fund a project, but doesn't really address the issue of how much it's going to cost. I'm going to skip it. So, how do we estimate costs? Project teams normally prepare cost estimates at various stages of the project, and these estimates should be fine-tuned as time progresses. Fine-tune meaning become more accurate. Okay? They become more accurate for two reasons. One is that as time goes by, we've already executed part of the project, so we can get historical costs just by asking people to get these data out of the accounting system. Okay. The other is that we learn more and more about the project that we're doing and our performance on it as time goes by. And so that as we get closer and closer to the end of the project, we ought to get better and better at projecting how much the total cost is going to be. It's also important to provide supporting details in the estimates, including ground rules and assumptions, sometimes called the basis for the estimates. A large percentage of total project costs are often labor costs. This is certainly true in software development projects. So it's important to do a good job of estimating labor hours and costs. Project managers should probably be able to go to financial people and um, get figures that they can use for planning for how much we're paying per labor hour. The big issue is how many labor hours we're going to spend. Well, we did that back um, in the scheduling. Okay, in the scheduling, we took into consideration both the duration and the effort. So, cost estimating techniques. So, here are three general approaches to how people estimate the cost of projects: analogous estimates, bottom up estimates, and parametric modeling. So, in analogous estimates, also called top down estimates, we use the actual cost of a previous or similar project as the basis for estimating the cost of the current one. The technique usually requires a good deal of expert judgment and is generally less costly than The others are because we're doing it at a gross kind of a level, but it can be less accurate. Bottom up estimates involve estimating individual activities and summing them to get the project total. So, project planning tools like Microsoft Project allow us to say for each activity what kind of resources it's going to use and to tell the product how much those resources cost, and it'll do the math for you. Okay. Now, one problem in bottom up estimates, and I've mentioned this in the course before. Um, the question is, what is your project going to get charged for? Okay. In terms of the people you have on your project and the resources that you have. You know, you might have computers and you might have offices and you might have things. Uh, a lot of times you just get a cost for the resources that are allocated to your project, whether they're utilized or not. Okay. So one weakness of a bottom up estimate is it says what your costs will be if you utilized everything 100%. Well, what if you were not able to utilize everything 100%? What if things have idle time? Well, in some organizations, those are just going to get charged to your project. Okay. So, one problem with a bottom up estimate is it might underestimate what your project is going to be charged. Okay. In some organizations, you're just charged for what you use, and what goes underutilized is somebody else's problems. But in a lot of organizations, you get the resources that you got, and they're yours until you give them back, and they charge you every month or every week until you give them back. And so the real cost isn't the sum of the cost of all the activities, but the sum of having the resources over the life of the project in order to get the activities done. And this was where bottom up estimates can underestimate the cost. Parametric modeling uses project characteristics and a mathematical model to estimate the project costs, and it's a more scientific um, version of analogous estimates. We look at previous projects and we try to analyze them in terms of key characteristics, and then we come up with a mathematical model, and then we use that to do the estimating. Cost estimating process. See what Kristen's team did in the book. Summary information was documented in the cost model. Just as projects are unique, so are cost estimates. Consult with internal and external experts and organizations for assistance. Again, one important thing is, what are they going to be charging your project for? Okay? If they're going to be charging you for everything that they allocate you until you give it back or they take it back, well, then that is going to drive your aggregate cost. So it's not surprising that we're seeing a spreadsheet here. Here's the spreadsheet that we're using for, I think, the project from the book. Okay. So if you look at the total cost is just under $1 million, $993,300. And it's apparently they had done the WBS in terms of these PMI process group categories, and all of our activities are under them. And then for each of these, we have, let's see, we've got labor. So this looks like labor hours. This looks like dollars per hour. This looks like internal dollar total. So this is the extrapolation of those two. Okay. Uh, how do we know the labor hours? Well, it's the estimates that we put when we were developing the schedule. It, it's the it's the uh, it's the effort. Okay, it the staffing, the number of people that we allocated times the duration. How do we get the dollars per hour? Well, we get it from our financial people. We get it from, the accountants and financial planners. Here, and so involved here? It might be pay, but it could be other things too. It could be pay, it could be benefits. There might be other things like how do we get charged for office space? Well, that could be part of this. Okay, there could be all kinds of things that they would tell us to, to put into our dollars per hour cost. So it's the opposite side of the question. What are they going to charge us for? Right? External labor, these are things that we're buying on the outside from consultants and such. Higher rates. Then we've got the total labor. So labor is a little bit more than half of this. 600,000 on a million. Okay. Non-labor. So these are things that we bought. Okay, and I forget what exactly we bought. These are training things. So these are maybe training modules that we bought from some kind of training vendor, and then we modified them. Okay, okay, and then we add all of that up. I don't see any travel. Maybe travel will go into non-labor. I don't see any. Um, what else might we have? Anything your project is going to be charged for, you've got to find some way to get into the sample cost estimate. Okay, and that's what you're trying to estimate. Okay, so when they did it all, they came up with $993,300. All right, cost budgeting. Project cost budgeting involves allocating the project cost estimate to tasks over time. Okay? Why do we need to do that? Well, several reasons. One is that somebody has to sign off on our spending the money over time. Somebody has to be planning to get the cash in the organization so that we're ready to make the expenditures and we can afford to do it. So that's part of what we have to do. The other thing is that we're often partway through the project when we're trying to figure out how well we're doing. And knowing how much we planned we would have spent so far is helpful. There is this approach that I mentioned earlier called earned value management that allows you to tease out how well you're doing by keeping information about cost and time. The tests are based on the work breakdown structure for the project. The main goal of the cost budgeting process is to produce a cost baseline. That's what we're going to expect to pay out over time. Okay, and that's going to allow us to measure and to monitor the cost performance. This is a great graphic. Okay, so um, here we have so here's the total project budget. Okay, I'm sorry. Here's the total project budget. So here's the activity cost estimates. Okay, and then we have some cost buffer. We call cost buffers reserves. It's the activity contingency reserve. Okay, so then these make up the cost of the work packages, okay? And then the work packages are the bottom level items on the work breakdown structure. Again, we're organizing the schedule and the budget according to the work breakdown structure. Okay, and the very bottom level, the level that has activity and cost, those are called work packages. Okay, and then uh, it's customary to have a reserve above that. That's typically would be within the purview of the project manager with approval. Okay. So then we have control accounts, and control accounts is this would be this would be the spending. Maybe it would be by category. Okay, so this would be the total amount of spending that we're expecting by categories, the lines of the general ledger accounts. Now, this becomes the cost baseline. Senior management can have a reserve of its own. Okay, uh, with that they're going to promise to senior management or the shareholders or mm, stock market analysts, right? Okay. So what's interesting is we have this idea that, yeah, maybe we have a reserve that we put on individual activities. Then we have a reserve that we're going to add to that in terms of the aggregate of them. And then that's going to become the cost baseline for the project. And then the management reserve is going to cover um, maybe this is to cover, in fact, things that go wrong, but also increases the scope, right? So it's really interesting to see how this might break down. Now, we're talking about how this might happen over time. Um, this is a time, and these are the cumulative values. And we can see here that the expenditures are kind of lagging um, this cost baseline. Okay, so what's the cost baseline? Well, that's just all the costs that we predicted when we predicted to spend them. Okay, and so as you can see, we started the project later than we thought. Okay, so we were lagging behind the expenditures for a long time, but then at a certain point, our budget, we're going over budget. Okay, but because of the management reserve that senior management added on, we're over the budget that the project team had, but we're under the promised budget that senior management had, and then we're we're later. Okay, because we didn't get to the end. We're going to get to the end now. We got to the end a little bit later. We spent a little bit more. We started later too. Okay, but we're still within this management reserve that's been promised to either senior management or the shareholders or to stock analysts or whatever. Okay. Um, so what went wrong here? Kathy Schwalbe likes these. The first of these is a story about how the National Health Service in the UK ran over um, a new information system that they thought was going to cost about 25 billion, and they spent 55 billion. I think they thought it was going to cost 29 billion, and they spent 55. And here, the Olympic Games, they talked about typically have an average overage of $12 billion. So there are all kinds of projects that run over the budget, okay? And while they're doing it, okay, there's a lot of angst and a lot of people asking questions. There's a technique that I talked about called earned value management that we're not talking about the details of here, but I have found it very positive. You can take all of that baseline information that you have and you can say, okay, well, given where we are today, how much do you think this thing is going to cost now? And when do you think we're going to be done? And it allows you to project that. Okay. EVM, earned value management. Um, and this is the sample cost baseline. So this is just, it looks like we have a 12-month project, okay? And we've got $993,300, okay? Because what we've done is we've taken the implication of our schedule, okay, and how we're going to use up the resources. And we've said, here's what we expect to spend in each of the months, and it's going to equal to the total of our expected cost. So that's how we got this, sorry, cost baseline, this solid line. That's where that came from, okay? So, how might this be different for Agile or hybrid? Okay, well, I've made some comments all along. I'll make a couple more here. Instead of creating a detailed schedule for all the activities required to complete an entire project, Agile teams focus on the most valuable work that they can complete within each iteration. This approach is often called time boxing. A time box is the previously agreed upon amount of time during which a team works to complete a goal. A sprint, for example, is a time box of 30 days or less. And I like to recommend 14, and a lot of people do. What about dependencies? Well, ideally, one Scrum team can perform all the work in their Scrum backlog. If there are dependencies within backlog items, the team should identify them and work on them accordingly. So we ought to get to the we ought to take things that are kind of predecessor activities and be pulling them up towards the front. Now that can be challenging um, when we're planning a sprint at the very beginning of the sprint. We plan the sprint. We might have the product owner who's a representative of the business. You may have them asking for things that are going to have the biggest payback, okay? But they may not really understand the dependencies. So they may be asking for things we can't do yet because we have to do other things first, okay? So the the rest of the team has to at least understand the dependencies and say, yeah, I understand that from a business value point of view, you would like to have that be in sprint one, but we can't have that in sprint one because we can't do it until we've done these other three things. So let's do them in sprint one and get that thing into sprint two. That's the point we're making here. When there are multiple Scrum teams, you can hold a Scrum of Scrums where representatives from each team meet to coordinate efforts and dependencies. Okay, so maybe there's an opportunity there to have the same kind of conversations. Um, there is another approach that's not Scrum called Kanban, which I call Kanban in my American way. It's a Japanese term meaning visual board. The Kanban method means to design, manage, and improve flow systems for knowledge work. Again, the kind of projects that people from the iSchool are doing probably are going to be related to knowledge work. It also allows organizations to start with their existing workflow and drive evolutionary change by visualizing their flow of work. Limit work in progress, that's a big item, and stop starting and start finishing. So everybody is talking about things. The influential people in um, the waterfall approach are talking about limiting multitasking, right? Uh, the um, in the agile approach, the Scrum people are talking about having short sprints. Again, a lot of people are recommending 2 weeks. Okay, you can only work on so many things. That limits multitasking. Okay. Here, the Kanban folks, which are another flavor of Agile, okay, are talking about limiting work in progress. How many activities do you have open at the same time? Limiting multitasking. So everybody seems to, there seems to be consensus that multitasking is a risk that we want to avoid. The Kanban method does not use time boxing, does not define any specific roles for the team, things like Scrum Master, Product Owner, and all that kind of thing. And it focuses on cycle time. Again, one of the biggest things here, reducing work in progress. And this is a sample Kanban board where we have requested. This is a kind of uh, the to do. We have uh, in progress or in process, and then we have the done. Most agile teams use this kind of a board for things that are in the sprint, whether they say that they're using Kanban or Kanban uh, or not. This idea, I mean, a lot of people, this is something I use in my work every day. I've got boards that I put together on Trello that have got 3 columns in them, and that's what I do. You may do so yourself. So you don't have to be saying that you're a Kanban team in order to use this kind of uh, chart. Cost planning for agile hybrid project. Unlike predictive projects, therefore, there's no total project a budget or detailed cost estimate for the entire project or agile project. I don't believe that to be true. Okay, that's what she says in the book, and that's what it says here on the slide. I think in our course where we're reading the book by Mark Layton and his collaborators. Uh, we we believe that one can predict the costs of a project on the basis of how many sprints we expect to have, okay, and then how many other costs we expect to have. So this claim that nobody in the agile world is predicting the total project cost is, I think, false. There is some estimating involved when using an agile approach, but instead of using hours or dollars, most estimates are done in a relative fashion, and we're going to be learning about that. Relative estimates are created by comparing work or grouping it by equivalent difficulty based on factors like risk, complexity, and required labor. Uh, some teams use t-shirt sizing. So they'll say for a particular user story or other unit of work that gets onto the backlog, is it a small, a medium, a large, an extra large, or an extra extra large? So they can do that. Okay, so that's putting everything into one, two, three, four, five buckets. Okay. Uh, Another thing that Agile teams do is they use this Fibonacci number system in order to assign a number of points to each of the pieces of work. The Fibonacci number system is useful in that you're not trying to make small differences in things. Okay. It's either a one or it's twice as big. Okay. Or it's nearly twice as big, or it's nearly twice as big, or it's nearly twice as big. What works about the Fibonacci number system is we're not classifying things in very fine grained things. It's a rough classification. So here they're saying that they're giving things between 1 and 21 points, and these are the values that they give. And this is 1, 2, 3, 4, 5, 6, 7, and this is 5 of these. So the idea, whichever the approach your team takes, is going to be about the same. The bucket system extension of planning poker, where there are many user stories in the team, is large. So the idea here, and it's pretty well described in the Leighton book, where you just get a team and you all go around and you try to put each of the pieces of work, primarily the user stories, into some kind of a size bucket. Okay. Um, these kind of things are called affinity estimates. Okay. Oh, there are links here in the book to some videos. There's one from somebody from Smartsheet, who is a project planning tool. There's one from a guy from Mountain Goat Software on this uh, agile estimation poker. And then there's some Kanban stuff. Here is a here is an attempt to take the user stories uh, and give them a relative size. Okay. So what's going on and we're going to, as we read through and we talk about the estimating stuff from the Leighton book, we're going to see that agile people tend to want to estimate things into size categories. Okay, and they like to do it in terms of points, these points that are coming out of the planning poker, because here's what they want to do. They want to add up the points in every sprint that we complete, and they want to get this idea that a team has a velocity. The velocity is how many points they are able to deliver in each sprint. Okay? And of course, the velocity from one team is going to be different from the other because these numbers have a different meaning for different teams. There only has to be consensus among the team about what these t-shirt sizes or what the points actually mean. But to use velocity, you need points, not t-shirt sizes. So you would have to translate the t-shirt sizes into points. And maybe you just would do it using the Fibonacci number system. I don't know. But the thing is that at any given time, when you look at your backlog, it has a certain number of points in it because you'll have estimated all the stories like this. Ideally, you'd want to do it with points. Okay, so they're going to need a table to translate these t-shirt sizes into points. And then how do we know how much of this we can get done in the remaining sprints that we have? Well, we look at our emerging velocity. And if our velocity is that we're doing 20 points per sprint and we've got 300 points left on the backlog and we've got 10 sprints left, we know that we're probably going to get uh, 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 2/3 of that done and not all of it. Okay. So the reality is that the basic thinking that is underlying time and schedule and cost in predictive waterfall projects and in agile projects, the thinking is not that far different. Okay. Um, how do we know how big pieces of work are? Well, we make an educated guess. We're doing that on the waterfall side, and we're doing it here on the agile side. On the waterfall side, we guess in person hours. Here we're guessing in points. Okay, and if we do the t-shirt sizes, we convert them to points. Okay, uh, eventually we're going to find out on the waterfall side how well we're doing against the estimates. Okay, and if we're wrong, we're going to have to adjust them. Okay, here on the agile side, we're going to find out what our velocity is in terms of how many points we're able to burn up in a sprint. Okay, we're not going to have to adjust our points, but we're going to have to adjust our prediction of how many stories are going to get done in the amount of sprints we have left. Okay, so that the places where these estimates come from and our ability to look at the big view and have some idea about how long it might take to complete the project, they're not super different. I mean, they're clearly different, but they're comparable. And I think the more that you can see that they're comparable and find some ways to kind of translate one into the other, the better off you're going to be. And that brings us to the chapter summary, and I'm going to leave you there for you to read that yourself, and I'll say bye until next time. Bye bye.